Good evening, sir.
Good evening, sir.
Yeah, thank you, sir. Good evening, everyone.
Good evening, ma'am.
Good evening. So, shall I begin the class?
Yes, ma'am.
Yes, ma'am.
Yeah, thank you.
सभी पार्टिसिपेंट को नमस्कार।
Namaste, sir. So give me a second. I'm just sharing my screen. Hello. Well, talked about the from today. I'm starting with the parametric test, right? So I'll firstly talk about the parametric test. Fine. So I think yesterday when I said non-parametric test, I talked about that when we are not bothering about the distribution of the data, especially the normal distribution of the data. In that case, we are using the non-parametric test. And apart from that, I told you that we are dealing with the categorical data, and in that case, we can go for the non-parametric test. For parametric test, condition is that we are generally bothering about the normal distribution of the data. Apart from that, we will be having the categorical as well as the uh, numeric variable available with us. And then we need to check whether the numeric variable is normally distributed or not. On the basis of that, we are deciding whether we'll go for the parametric or non-parametric. Means when your numeric variable is following the normal distribution, in that case, it is go for the parametric test. So parametric tests are concerned about the normal distribution of the data. This is the main assumption when you are talking about the parametric tests, right? In this category, there are various tests available like t-test, ANOVA, regression, etc. Right? When I talk about today's agenda, we are talking about the t-test. So when I discuss its concept, I say t-test is a parametric test. First thing. Second thing, and the other name of this is students t-test, right? Then when you're talking about the t-test, the main purpose is you want to see the mean difference, right? So main purpose or to check the mean difference in the variable, right? Yesterday when I talked about the chi-square test, I said there you can find the association between the two categorical variables, or you want to see the uniformity of the frequency distribution, right? Whereas the t-test purpose is to find the significant mean difference in the variable, right? So that way we can say we are using the t-test. Generally, there are concepts like when the sample size is less than or equals to 30, you are going for the t-test. Apart from that, there is one more important condition available in statistics, which is when you are knowing population SD. When you are not knowing the population SD, in that case, you are going for the t-test. So that means condition is that apart from sample size, second condition is you need to see whether the population standard deviation is known to you or not. If it is known, you can go for the Z test. If it is unknown, you can go for the t-test. So this is the other condition which is important for us to check. Usually, when I talk about softwares, you will check when I have, I think we already downloaded the or added the add-ins. So in the data analysis toolpack, you can find we will be having t-test available and z-test is also there. You can see there, right? So z-test 2 sample for means is available and 3 categories of the t-test is available there, right? So when sample known or unknown, it is a very important criteria to deciding upon whether you are applying the t-test or z-test. But when you are going for the other softwares than Excel, I'm talking about suppose SPSS or maybe some other softwares, programming languages, Stata, MATLAB, etc. Usually there is a t-test easily available for us. Reason being why people are applying t-test instead of their having a large data set available. So reason is very simple that there is a concept in the statistics named as central limit theorem, which is based on the concept of when the sample size is increasing. So generally your sample is tending towards to the normality, right? So that is why that means your large sample is meeting with the normal condition and t-test is almost behaving like the z-test. So people can use t-test there, right? So this is the condition, that is why people are using nowadays t-test over the z-test. Talking about the types of the t-test. So there is one sample t-test and two samples t-test. One sample t-test meaning is that we will be having a single sample. Single sample meaning is one variable we will be having, right? So we will be having single sample or we will be having the one single variable or one variable available with us, right? Now, when I'm having a single variable available with me, question comes how I can check the difference in the mean, right? So in the case of one sample t-test, you need to compare your sample mean with the population mean. Numeric or continuous, right? So one numeric variable you will be having that data, you will be having the data for that variable, and apart from that you need to have the knowledge about your population mean, because you will compare the sample mean with the population mean. So here you are and population mean, right? So this comparison you need to make in the case of one sample t-test. Second category of the t-test is two samples t-test. In case of two samples t-test, there is again one more classification. Classification is that here we will be having two type of different t-tests, that is independent samples and dependent sample t-test, right? So that way you can say broad classification is one sample and two samples, but in the two samples there is one more classification. You can divide this into the two categories. First one is independent samples, second one is dependent sample, right? When I say independent samples, right? So Here in case of independent sample status, we compare means of two independent samples, right? So we compare the means of two independent samples in case of independent sample status. Independent samples means two unrelated. So two unrelated samples you need to have, and that way you are comparing them, right? Variable requirement here. In this case, variable requirement will be, we will be having one independent variable, and we will be having one dependent variable, right? Independent variable, what should be the nature of your independent variable? It should be categorical, especially the nominal scale variable, right? And categorical variable with two categories or groups, right? Dependent variable will be numeric. Numeric meaning interval or ratio scale variable, right? So this is the variable requirement in case of independent sample status. For example, so to understand that where you are applying the independent sample status, suppose I'm having the marks of students belonging to two sections, right? So if this is the example written here, that I'm having the marks of student belonging to the two sections, so may I expect anyone from you who can tell me if this line number 22, if I'm showing you, in this line, how many variables are there? Anyone who can attempt?
Section and marks, two variable.
Section and marks, two variables. Very good. So here you can say I'm having the marks variable available with me, and I'm having the section variable available with me. So marks will be definitely the numeric variable, right? And section will be like section A, B, C, something. So maybe it is your nominal scale variable, right? And I have told you we need to compare the marks of belonging to the two sections. So when I'm comparing the marks of the students of the two sections, so you can see according to the independent sample status, variable requirement is you need to have one independent variable that is categorical, that is section I am having, and it is a nominal scale variable, and here you will be having minimum two categories. So I have already told you we need to compare the marks of two different sections, right? And then you need to have one dependent variable, which is in our case numeric, and which is in our case a marks variable, right? So now if my purpose is I want to compare the marks of two different sections, it is quite obvious when I'm comparing the marks. So I will say whether the mean marks of one section is same as the mean marks of other section or not. So whenever I'm going in the comparison of the mean marks, I will go for the independent sample t-test, and two, as you can see, I have written here, you need to compare the means of two independent samples. So which are the two independent samples here? Section A and section B. So that means our student who is the part of section A, he or she will not be the part of other section, right? Is it clear? So that way there will be the unrelatedness in the two groups, or maybe two groups are independent in nature, right?
Ma'am, if we have more than two categories, then we apply different test.
Sorry?
If we have more than two categories, then we apply different test.
Yeah. We will not go for the t-test.
Okay, in that case, what test we will apply?
We are going to study these things in the upcoming days.
Okay.
So I think we need to hold on to this. I am only talking about the t-test today. So I told you Fine. So this way, this is the independent samples t-test. Now the next category in the two samples t-test is the dependent samples t-test. So what is dependent samples t-test? Here again, the purpose is to compare means. So when you need to compare the means of two dependent samples, so to compare the mean of two dependent samples, in that case, we will go for the dependent samples t-test, right? Now, variable requirement will be
One.
yeah, variable requirement will be we need to have one variable that will be the dependent variable and it is numeric, right? Apart from that, we will be having this one sample only, right? Meaning is that because here we are talking about the dependency in the samples, right? So it is only possible when the one person is or one person value you are or whatever variable you are measuring for that variable from the same person you are collecting the data two times, right? So that way it is possible to maintain that dependency. That means in the simple word, if I want to say, I can say whatever the one sample I am having, suppose I am having the marks of students, right, who are studying from the suppose audio method, right? Now for the same student, suppose a new method was launched, that is a video method, and those students who are studying from the video method. So that means for the two students from two different methods, from the same students for two different methods, marks will be available with you. You can compare in the marks, right? So that way it is a case of dependent samples. Or apart from that, maybe other example I can say, because generally the dependent samples t-test, also known as paired sample t-test, is usually used in the case of experimental studies, right? For example, suppose I am having, or suppose being a medical practitioner, suppose some of the patients are visiting to me. So maybe those patients, those who are visiting to me are the patient who are having a problem of blood pressure, suppose, right? So maybe I can take their blood pressure before giving them some treatment, right? And after giving them some treatment, I can let their BP scores afterwards, right? So that way you can say same person's BP scores I have collected twice, one before treating them and second before after treating them, right? So that way you can say this is known as the dependent samples t-test. That means wherever the before, after, pre, post kind of conditions are coming, there we can apply for the dependent samples t-test, also known as paired samples t-test, right? So meaning is very simple. That means I am having a one sample available with me. For the same sample, whatever variable I am measuring, I will measure that variable twice, and there will be some time gap in those two conducts or in those two measurement collection, right? Say for example, maybe any company is claiming that if a particular company, if a particular person is taking the diet plan they are suggesting, so maybe that can help to reduce their weights, right? So suppose there are 10 people available. So before giving them a diet plan, company has taken their weights, right? After giving the diet plan, suppose after 1 month or 2 months, after taking that diet plan or following that diet plan, again company can collect their weight scores, right? And that way you can say for the same 10 persons, company will be having the weight variable available, but there will be some time gap in the two collection, right? So that way you can see in this condition, in this case, we can perform the dependent samples t-test, right? So these are the three different varieties of t-test. I think, I hope I'm clear on this.
Yes, ma'am.
Fine. So this way, these are the things. Second thing, when I talk about the assumption, because I think I told you parametric tests are generally bothering about the normality of the data, right? Apart from normality, usually you need to check outliers also. You need to also check the homogeneity of variances, especially in the case of independent samples t-test, right? So in that case, what you need to do, what you will do, usually as Excel is having some limitations, right? So there is a problem with Excel, but still, I think I told you how to perform descriptive statistics. And in descriptive statistics, using the skewness and the kurtosis parameters, somewhere you can have some idea about the normality of the data. So once, if we are using Excel for performing the t-test, and as we are knowing, the assumption is to check the normality. So it is generally, you can check using the descriptive statistics, right? So that way you can do this, right? Second thing is that once I have told you data analysis tool pack, once I'm going in the data tab, in the data analysis tool pack, you can see I'll need to go down as all the tests are listed alphabetically. So you can find here, there are 3 types of t-tests are mentioned. First one is t-test, pair to sample for means. Second one is t-test to sample assuming equal variances. Third one is t-test to sample assuming unequal variances. So if you will pay attention and you can see this thing, that all the 3 tests of the T category listed here are belonging to the second category, that is the 2 samples t-test. 1 sample t-test is not available in this particular list, right? So problem is, if 1 sample t-test is not available, what you can do? So solution is that you can use a function. We are having the function of t-test. Using that function, we can calculate the t-value for the 1 sample t-test. This is we can do in case of 1 sample t-test. But for the remaining 2 categories, independent samples and dependent samples, we can take the use of this data analysis tool pack. I think it is clear what I said just now. Yeah.
Yes, ma'am.
Fine. Okay, so I think now it's time to perform t-test, right? Using Excel. So I think sheet I already shared on the WhatsApp group, expecting you to download it and open the first sheet named as demos 1 sample. Once you people are ready, please give me a nod so that we can proceed.
Yes, ma'am.
Shall I go ahead?
Yes.
Fine. Give me a second. Fine. Now you can see the data which I have provided to you is given here, which is indicating you we are having the height in inches available with us, right? Now, the important thing which I think I already mentioned when I was discussing the concept, I told you, you need to have the idea about the population mean, because you need to compare whatever sample you are having, you need to compare its mean with the population mean. So you can find in the Excel sheet, I have also mentioned the mu value. Mu is what? Mu is the population mean. Visible, I hope, right?
Yes, ma'am.
I hope it is also mentioned in your sheets also.
Yes.
Fine. So now you can see how to perform the t-test. Because it will be a manual calculations. I already told you, I already shown you, right? So I said that in the data analysis tool pack, 1 sample t-test is not available. That means you need to take the help of function. And I have already given you the function which is helping you to calculate the p-value. So if you will see the functions for the p-value, which is starting from t.dist.2t. In the brackets, it is asking you to provide the calculated value of the t. Whether it is a 2-tailed test, whether it is a 1-tailed test, in both the conditions, we need to provide the calculated t value, right? Right? Friends, it is okay?
Yes, ma'am.
So meaning is that we need to firstly calculate the t value, right? Now, how to calculate the t? You can see we are having, I have already given you the formula which can help you to calculate the t value. Formula says t equals x bar minus mu divided by standard error of mean. Right? This is the formula. Now, mu I think I already provided to you. That means in the numerator, you are having the mu available with you, but we are not having the mean. Next one is you need to also calculate the standard error of mean. These things you need to calculate, and in your sheet I have already provided you the formula which is helping you to calculate standard error of mean, which says it is standard deviation divided by square root of n, right? So now if you are also following me and you are also performing along with me, I'm asking you to please write few things, right? So firstly, you need to calculate the sample mean, right? Done.
Yes.
Then you will calculate sample standard deviation. Done. Then you will count, or maybe you will then say you need to calculate the n value. N is nothing but it is your sample size, right? Fine.
Yes, ma'am.
Done. And then we will calculate the t value, right? So firstly, we are calculating these three things, and then we will proceed for the calculation of the t value, right? So here I have written sample mean. Anyone who can tell me how I can calculate sample mean?
I'm taking average of the height.
Good. Thank you, ma'am. So we will calculate the mean using the function called average. You need to write equal. Then after equal, you will type the function average and you need to provide the range of your data. Right? You can close the bracket and can press the enter. It is giving you the mean of the sample. That is x bar. Right? Right, everyone? So this is
Yes, ma'am.
this is your x bar. So now you can see we are having x bar available. Mu already is provided to us. Next thing you need to calculate the denominator part. For that you need to have the standard deviation. And how I can calculate the standard deviation?
Using STDEV.
Very good. It is STDEV. This function we are using here and providing the range of the data, closing the bracket, pressing the enter, it is giving me the standard deviation of the sample, right? For calculating the n, what I need to do here? How I can calculate n?
Count.
Very good. We will use here the count function and selecting the range of the data, closing the bracket, and it is returning me the sample size, value of n, which is 12. Done. Next, I need to calculate standard error of mean. That is this part of the formula, which is the denominator part. So standard error of mean is nothing but it is the standard deviation divided by the square root. Square root function is available and you need to provide the n. Fine. Is it okay?
Yes, ma'am.
So the standard error of mean is coming here. Now I will calculate t statistic. So t statistic is nothing but this is this particular formula. So which is telling you this minus 66 divided by standard error of mean. Done. Done.
Ma'am, please repeat standard error.
Okay. The standard error is the standard deviation divided by square root of n. So you need to select this standard. After equal, you need to select the standard deviation which you have calculated. divided by square root of n. That is this 12. Done?
Yes, ma'am.
After this, we will calculate the t statistic, that is this t value, which is x bar minus mu. So it is x bar minus 66 divided by the standard error of mean. Done? Done, everyone?
Yes, ma'am.
Yes.
Getting the t statistic as 4.92. Then now we will calculate the p value. So for p value, we need to use the function called t dot dist dot 2t. So we are performing the we are getting the p value for the two-tailed test here. So I'm selecting this function. It is asking me to provide the x. X is what? It is nothing but the value you have calculated just. After this, you need to write the degrees of freedom, which is this minus 1. Done?
Ma'am, can you please help me to find out the T-stat because I'm getting a different answer.
Okay. So can you tell me how I can help you? What
Ma'am,
you
I've
have
got
been
minus 70 I got.
I think it is because you have not enclosed
Oh.
the numerator value in the brackets.
Okay, understood. Thank
Okay.
Ma'am, can you tell me T-stat again?
T statistic. Okay. So it is, you need to only follow the formula, means, ma'am. You do not need to see what I did. If you are knowing the formula, it is already written. It is x bar minus mu. X you have already calculated. Mu is 66. So x bar is this minus mu is 66 divided by the standard error of mean, which you have just calculated here. Done? I hope it is done. Please give your confirmation so that I can proceed.
Yes, ma'am.
Fine. Then p value is also calculated by every one of you.
Yes, ma'am.
Fine. So now on the basis of p value, can anyone tell me what will be the interpretation here? How I can interpret the results now?
That population mean, sample mean is not equal to population mean. I think original hypothesis is sample mean is equal to the population mean.
Okay.
And since the p value is less than 0.05,